Welcome to qnawire.
In part A, we're asked to find the acceleration during the crash. The first thing to do is convert 311 kilometers per hour into meters per second. To do this, we multiply by the conversion factor, 1,000 meters in 1 kilometer. This will cancel the kilometers and leave us with meters. And then we want to cancel the hours, so they go in the numerator. We want to turn them into seconds, and 1 hour is 3,600 seconds. When we multiply this out, we'll get 86.4 meters per second. Now, in order to determine the acceleration, let's write down our knowns. Our y minus y naught, the distance traveled during the deceleration, is negative 0.81. Our initial velocity is negative 86.4 meters per second. Our final velocity is going to be 0 because it comes to a rest. And in order to find the acceleration, we're going to use vy squared is equal to v naught y squared plus 2 times the acceleration in the y direction times the distance traveled, y minus y naught. This yields 0 is equal to 7,465 plus 2 times the acceleration with respect to y times negative 0.81. Solving this for the acceleration with respect to y, we get 4,608 meters per second squared. And then we can divide this by 9.8 in order to get in terms of g's. When we do that, we get that's equal to 470 g's, roughly. And that's the end of part A. Part B asks for the force exerted during the process. And so we're going to use the sum of the forces in the y direction is equal to mass times acceleration in the y. We just found the acceleration. We have the mass, so now we just need the sum of the forces. Now, if I draw a free body diagram here, I have gravity pushing us down. I've got an acceleration up, and then I have the force exerted by the ground up, and we want to solve for this guy here. And so the sum of the forces gives us F minus mg. Those are the sum of the forces. The mg is negative because it goes in the downward direction, and the F is positive because it's in the up direction. And this is equal to m times a. This means that F is equal to m times g plus a, which is equal to 210 kilograms times 9.8 for g, and then 4,610 for a, which is what we found in part A. This gives us an answer of 9.7 times 10 to the 5th newtons. And then if we want to convert this into a factor times the weight, we need to turn these accelerations into the g's. When we turn these into the g's, we can replace the mass with the weight. And so the force is also the weight, I'm just going to leave it as w, times these accelerations in terms of g's. So 9.8 is just 1g. And then 4,610 we found in part A was 470 g's. And so this is equal to w times 471. And that completes part B. Part C is asking for the time it takes for this to happen. And for this, we're going to use y minus y naught is equal to 1/2 v naught y plus v times t. We're going to solve for t, and we get 2 times y minus y naught over v naught y plus vy. Plugging in the values that we know, this gives us a value of 0.0187 seconds, which is our final answer.